Okay, it is 3:02, and I think I'm going to get started over here. Thank you, everybody, for coming to our fourth iteration of the Bioinformatics and the Genomics series. Today, we're going to be talking about Nextflow for streamlining biosciences analysis pipelines, which is going to be a small deviation from what we have talked about so far. Why is that? First of all, we did talk about what tools we need in bioinformatics. We talked about where we run our bioinformatics work and how to run a small pipeline. As we start learning about all of these moving parts, we also need to understand what are some of the more important techniques that we require in order to maintain these pipelines in check. So this week and next week, we are talking about technologies that help us with pipeline management. This week is going to be Nextflow, next week SnakeMake, before coming back to the biology itself. It is also important for me to announce that November 19 and the 12th, November and 12th and 19th, we are going to have an intensive transcriptomic only bioinformatics session, which you may be interested in, and therefore please do watch out for any announcements coming out from the University of Arizona's Data Lab or the Data Science Institute. With that said, let me move some things around. I'm going to open up, excuse me. I'm going to open up Cybers here, like it is now tradition. And I am going to start a bioinformatics analysis. I'm just going to start it. I'm going to go to the Apps tab here on the left. It's going to reload the page a second. And I'm going to click on the JupyterLab Bioscience. I'm only starting it now. I'm not running anything. I do also want to mention that today is going to be relatively theory heavy. So don't worry too much about running any code or staying on top of the code. I'm going to select 8 minimum CPUs, 8 maximum CPUs, and a minimum memory of 8. We're not going to be doing too much today with this application. I'm then going to click Next and Launch. And at this point, the JupyterLab Bioscience should be starting. Whilst this happens, I'm going to go back to the University of Arizona's Data Lab Bioinformatics Wiki, where you can find all of the material that we're going to be covering throughout the workshop series. And I'm going to be posting this in the chat. If you do scroll down this page, there we go. Please do go down to 0924 using Nextflow for streamlining bioscience analysis pipelines. Over here, do click on material, and I'm going to copy this and paste it in the chat as well. Okay. Gotta close a couple of windows. There is going to be a couple of images on things that look like workflows, and these are very much like pipelines. And I do want you guys to get a little bit accustomed to it, because we may or may not get lost in this. It's a little bit of a maze, honestly. The schedule for today, within the next few minutes, I'm going to introduce what is Nextflow, and then the importance of pipeline management and the direction of bioinformatics. And then I'm going to explain a little bit of Nextflow syntax and pipeline execution in general. And lastly, I will give you some resources and closing remarks where you can learn a little bit more on Nextflow. At this point, we have already started a terminal or the Jupyter lab in Cyprus, where we do have access to a terminal. And today's expected outcomes. I expect today for all of you to walk out in such a way that you understand the concept and significance of workflow management in bioinformatics. Identify why you will want to use a data management tool such as Nextflow, as well as understanding a little bit of the Nextflow syntax, and try it out yourself. Just so you know, the pipeline that we are running today through Nextflow is foolproof, as in you only need to run a single command and it will work. So don't worry too much about doing code today. However, what I will be doing is that I'm going to run it at some point. We're all going to be running, and we are going to try to figure out what is going on in the back, under the hood. Forewarning, this is not going to be a complete a workshop which completely covers Nextflow. That is simply just impossible. This is just for you to understand how Nextflow works and what are its components. To help us, we are going to be using the organism G. gallus, which is the original chicken. And we have a number of files that have been made open for everybody in Cyprus. We're going to get these files as the workflow progresses. The pipeline that we are going to be doing is one, indexing a transcriptome, performing quality control, performing quantification, and create a multi-QC report. At some point today, I'm going to look like this. If you don't know what this is Charlie from It's Always Sunny in Philadelphia. And in the episode itself, he's trying to understand what is going on, what is the conspiracy. And I tell you what, going through Nextflow is going to go make me crazy. So I apologize beforehand. I'm going to use the next jokes next week, because this is going to be a little bit out of the ordinary. So, getting things started, it is important for us now to get the data. We're not going to be running the data. Let's just get the data such that we are all ready to go. In order to do this, we do need to get the data first. So if you do go to your Cypress application, should be running right now. I'm going to go to analysis. I then click the terminal, where I am going to do go cmd init. That is go command init, pasting it in the chat, where you're going to press enter, 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 where it tells you your username. If it doesn't say your username, go ahead and enter it. Otherwise, enter, and your Cypress password. If you do not receive anything and you see something similar to the screen, that means that you have successfully, that if you have successfully logged in Go commands. Now, I have here the command necessary to copy the files from our data store. So please copy and paste it from the chat into the Jupyter Hub. What this will do is that it is going to download the FASTA file necessary for today, as well as the files that we're going to be aligning against it and doing some quality control. Okay, I just want to make sure here on the left, you have a new folder. It's called Nextflow tutorial, and it contains a transcriptome underscore qc.nf that is going to be our Nextflow file, and a data folder which has gallus in it and all of the files necessary. So as long as you have your Nextflow tutorial, we can put this aside and talk a little bit about Nextflow itself. Okay, I don't want to scare you, and therefore I hid it. And this is click here for the raw Nextflow code. If you do click it, it's literally a bunch of code that we will look in more detail later. But in case you did want to spoil yourself, I put it out here in case you want to understand it. But what is Nextflow? I'm going to park this over here. Well, Nextflow is an open source workflow management system that allows researchers to write and execute data-driven computational workflows. It is written in Groovy, which is a quote-unquote dialect of Java, and it's been around for a while now. I do believe it's been around since 2012, 13, 14, so the early 2010s. It is not the easiest to learn. It is not the easiest language to, well, Groovy, and therefore Nextflow is not the easiest language to learn, but it is extremely rewarding. So let's start with some of the more positive aspects on why Nextflow. One, it is portable. It does come with the possibility of having only a single executable file, and it can run on a lot of machines as long as you have Nextflow installed. It can also run on the HPC, as Nextflow supports Slurm and it supports the PBS schedulers, as well as cloud computing as well. Cloud computing, as long as cloud computing. Sorry about that. It is extremely scalable. Most of its scalability is automatic, as in you don't have to go and ask for how many cores you want to run something. It will automatically detect how many cores are available, and it will allocate those cores to the pipeline or that specific launch, that specific software launch. And it allows for reproducibility. Reproducibility is something that is extremely important when it comes to open science, when it comes to allowing your collaborators do work. And therefore, Nextflow just adds to that extra sweet spot of reproducibility. Uniquely to Nextflow, it's its ability to manage pipelines using a concept called channels. Channels are processes that quote unquote activate when they are needed, but remain active and use less energy when they are not. Later on, I'm going to be using an analogy of a kitchen to help us a little bit understand Nextflow itself. But imagine yourself being a chef. You are a sous chef cooking a dish, and all of a sudden you have a bunch of ingredients coming in and you have to cut them really, really quickly and move them on to the next chef in line in order to finish the plate. Well, it's not that as soon as you take and hand off your cut up ingredients, you turn off. You are simply waiting for the next few ingredients that come in. Other pipeline managers, like the common workflow language or SnakeMake, are not like this. They are what we call data-driven, in a sense that, well, the data comes in, and as soon as I push it out, I am done. This is a problem because in many cases, when the data comes in and the data is wrong, you get an error and the entire pipeline breaks. So channels allow for you to handle errors in a different manner. And therefore, it's one of those things that makes Nextflow worth knowing about. Another reason why you want to use Nextflow is because it has one of the more robust communities in bioinformatics, and that is the NF core or Nextflow core. I'm gonna open it up real quickly to show you what it is like. And the Nextflow core is, well, it's a community-driven website where you can host pipelines, you can find maintained pipelines, and honestly, these are extremely well maintained. I am going to click on ISOSEC over here. It has a really clean explanation of what this pipeline does, and the very detailed description of within the documentation itself. Throughout NF Core, people can open up their previous, for example, iterations of the pipelines, as well as opening up issues in a GitHub in case you want to improve on a pipeline or find a bug. But it is one of the more robust groups that there is in bioinformatics. So why Nextflow? Well, because you're always going to find help. And lastly, it's because Nanopore, one of the quote-unquote big three, if you don't know what I will call the big three are Nanopore, Illumina, and PacBio, officially is supporting Nextflow as its main workflow language. And therefore, it is just worth knowing Nextflow because one of the big three is directly supporting it. Not to say that there is no Nextflow support for PacBio or Illumina, but it's incredibly important to understand that Nanopore all of a sudden is saying Nextflow, you are it. There is a question, or there is a comment. The configuration seems like it will benefit from multiprocessing approach. Yes, since parallel process can proceed while some other processes stall and or wait. Yes, exactly. But the thing is that we don't control it. Nextflow controls it itself. It is smart that way. Don't necessarily know how it does it, but it is able to reconfigure where the parallel processing happens. So one of the greatest thing of Nextflow, honestly. Thank you for the question, Randall. Okay, I'll get a glass of water here just a second. I'm gonna cite now two popular alternatives to Nextflow. The first one being SnakeMake. SnakeMake has risen very quickly since its inception in early 2020. And it is flexible, very similar to Nextflow in that sense, scalable, and also very portable. It is preferred as it is written in Python or similar to Python. Meanwhile, Nextflow is stuck with an ancient language that is Groovy. I do want to say that I personally am not too big of a fan of SnakeMake. The only few iterations that I've had run into SnakeMake made me feel a little bit uncomfortable, but it seems to be extremely popular. And if something is this popular, it's worth looking into again. What you're seeing here, this is the quote-unquote star history. If you're not familiar with what stars are in bioinformatics, in the world of GitHub, at least, you can star a repository. Starring a repository means that you have a follower of that repository. And as you can see, whilst Nextflow does have a lot of stars in its repository, SnakeMake definitely had a really rapid rise. SnakeMake is also starting to have a more congruent community. Therefore, maybe it's just me. Maybe I need to go back and look at SnakeMake a little bit more. Another one is Galaxy, and if you have been in the game for a while, it is likely you have at least logged into, signed up for Galaxy. This is a web platform that has been around forever, honestly. And here is me opening Galaxy. And what allows you to do is that it allows you to string together a workflow. But because of how long it's been around, and because it is made to be very much point and click, it does lose a lot of its workflow ability. All of a sudden, although it helps you create a workflow, it doesn't have things like parallelization. It doesn't have things like sorry about that. It doesn't have things like allowing multiple tools to run at the same time. And therefore, Galaxy is great for beginners. I don't say that Galaxy is bad. It's just that you should probably use Galaxy if you're a beginner. Also, is another thing in the chat. Randall, that's exactly where I got it from. This specific graphic is written by Noah Lebovich, which is the Flow Deploy CEO. So congratulations, you found my sources. Okay, so now that we talked a little bit about Nextflow, why it is important, and what are its quote-unquote main competitors, I do want to say that there isn't a single answer to all problems. However, knowing what resources are available for your research needs can put you many steps ahead of the curve. So just keep that in mind. Just because I am a big fan of Nextflow doesn't mean that you should be one. Just because you like SnakeMake doesn't mean that I need to use it, but I may have to bend over in case Nextflow is not working for me. Okay, so I want to now talk about the Nextflow components. Nextflow is extremely complex, but it runs with mainly 4 components: processes, channels, workflows, and directives. A process defines a task that performs computations or manipulation of data, and each process specifies inputs, outputs, and a script to run. So this is a very small backbone, essentially, of the process. Here you have a process name, open squiggly bracket. This defines here on, we are starting our process. One of the first things that you do have to define is what your input is. And this can be, I'm going to show you in a second, this can be a direct path, or this can be a variable. What is the expected output? This can be a file or something that feeds into the next process, and the script itself, such as blast n, specific input, specific output. Don't fuss over too much about what these are. This is just theory so far. I do, however, present a small example where the input is the reads, the output is the aligned reads, and I'm running a small bow tie alignment in my script. This is the absolute minimum that goes into the process. Another thing that is worth pointing out, always make sure to use the right amount of spaces. And I found myself yesterday revising this lesson and using Vim and Nano, which are command line tools in order to modify this data. Bad idea. Too many spaces, too many wrong things. Use an IDE such as Visual Studio. They will very much help with keeping the spaces at the right length. So, processes are what run things. What else do we have? We have channels. And channels are used to communicate data between processes. They are used to collect data from files, create lists, or combine one process to the other. An example here is channel. From file pair, expect a tuple of samples in FASTQ format. If there is no file, output error, no reads found. If not, set read pairs channel. This is confusing, I understand. But what this is doing is, 1, define where the files are from. 2, if there is no files, tell me what to do and say no reads found. And 3, if you did find the files, create the pairs channel. Okay, so if processes run things, if processes run, my God, I forgot what to say. If processes perform computation and channels move data around, what comes next? Well, the workflow. The workflow is the one that orchestrates the execution of the process and defines the data flow between them. Just because the channel has something ready to go, it doesn't have the ability to go until the workflow says go. And a workflow is usually written at the end of your file, where you then define how the workflow runs. In this specific case, you have a workflow that from the read pairs channel asks to align whatever is in the read pairs channel into a line, which is our, excuse me, I'm going to scroll up a second, our process that we defined earlier. Now, I understand this is extremely confusing. Just trying to go as slow as I can. And if you do have questions, do ask. Lastly, I do want to talk about the directives. And directives are special notes and annotations used to control the behavior of specific processes and workflow. Unlike workflows, channels, and processes, directives live between the processes themselves, such as here we have a process name, and we have a directive which says value. In this specific case, let's say that our directive is use the conda package bowtie2. And in this specific case, we know that in the process align, it is going to be using the conda package bowtie2. Between you and I, directives are not always necessary. These are small notes and annotations after all. For example, if you do already have bowtie2 installed on your PC or your computer, you don't necessarily need to tell the process align to use bowtie2. You can just have it in the script. So, although important, you don't always need the directives. The usual workflow order in Nextflow is that first we have the parameters. So we did not talk about the parameters, and I feel bad now. I'm going to scroll down a little bit and maybe show you what the parameters look like. And excuse me, guys, but the parameters is what I have highlighted over here. And the parameters are the files that are going in, such as in this specific case, I'm saying what the reads are. Params.reads equal where the parameters are. And therefore, these always go first in your script, followed by the process themselves. So within the processes, you have things like what's the input, what's the output, what's the script, if there is any directives, and you can have multiple processes. And right at the bottom, you have workflows. All of the workflow is directed right at the end. If we were to piece together what's written, all of the small little example that I have so far, this is the example Nextflow file. Here at the top, I'm saying, hey, Nextflow, enable DSL2, which is the language needed for Nextflow to run. DSL1, it's now disabled, so perhaps that's not necessary right now, but it's always good to be explicit when you are doing compute stuff. And then I'm saying, hey, Nextflow, here are my parameters. They are in the data folder, and I'm looking for a tuple. And then the next thing after that is, hey, Nextflow, here's my first process. Use bioconda, excuse me, to call bowtie2. Also, this is another directive that means create a directory called results aligned. This is where your data is going to be deposited. Here, the input will read a path to the reads, which are specified here at the beginning, params.reads, and the output is going to be a path called aligned and the reads. You're going to get the names of the reads. I'm not going to go into the syntax of things right now. Then lastly, you are running a bash script with bowtie2. Secondly, we're running a quick fast queue where you're using the directive bioconda fast queue, and you're telling it where to deposit its results. And then you just run the script, and here you define the workflow itself, where define the channels file from file pairs, where the parameters reads is found, is going to output, if empty, cannot read the reads. If not, it creates the reads pair channel. And then it executes the process, first to align and then to carry out quality control. I apologize, this was extremely confusing. I do not mean for you to understand exactly what is going on right now by any means. I have, however, created a small click here for an annotated version, and here it goes into more depth into what each line does. So feel free in your own time to study this if you may. I'm going to close this now, and I am going to use a little kitchen analogy to help us understand what the heck is going on. Okay, if you've seen the bear, you know where this is from. If not, it's a question. Maybe a flowchart will be helpful. Yeah, that would be helpful, actually. I can't get you one right now, Randall, but a flowchart. Flowcharts are available in NF Core, and since this does come from a NF Core sister, maybe I will be able to get you one. Maybe I can mention this in the next iteration. Maria did share a training.nextflow.io. Thank you, Maria. That is a link that I will be sharing later on as well. It's a great place to really understand the Nextflow chart itself. But I'm gonna scroll up a second because there has been this chart right here, which kind of perhaps allows you to understand things. Let's not think about what I just mentioned, as in let's not think of bow tie, but as you can see where the fast queue data comes from, and are then fed into aligners, into FASTQ processes. And then here you have two channels being created. One will be your alignment channel, number 2, and 3 will be your quantification channel. The channels are always active. They're just waiting for data to flow through. And then you have your read alignment channel with SAM tools. And then 5, you have another channel which creates more quantification and summarization of all available, what are they called? Statistics, all the statistics available. So in this specific case, we have 5 different channels created, waiting for things to flow through. And you have a question?
Yes. Are you using channel and stage kind of interchangeably? Is stage the same thing as channel? Because on this graphic it says stage. Is that the same thing as a channel?
Right now, yes.
Okay, because it says there are 5 stages.
Yes.
Does that mean channel?
Yep.
Okay.
In this specific case, yes. I don't remember never running a single Nextflow file which has like 4 different steps. I've always been able to run a single Nextflow file with all of the channels and quote unquote stages ready to go. So okay, I'm gonna make this smaller, and I have digressed. I'm gonna go down to my little example of the kitchen. So imagine you are you're in a restaurant and you're running it, and congratulations, you open up a restaurant. What are the things you need in order to run the restaurant? Well, first of all, you need chefs. These are your processes where, well, the chefs are responsible for making the food a part of the dish. So imagine yourself as a chef. The food comes in, you prepare your little food, and then you move it on. The channels are a little bit like your ingredient delivery system, where you are taking the food from the chefs and you are moving it from one chef to the other. Let's imagine this as your files. In fact, they are coming from your input to a specific process. The workflow itself is kind of like the head chef. He is the one directing that, well, table 52 still hasn't gotten their tuna, and therefore it's telling you, the chef that's cooking the tuna, to move. So asking the channel to move the tuna to the person that needs to plate the tuna. And lastly, each single station in the kitchen has small little annotations, small little directives. And within these directives, it's written, oh, this is the tuna. I have to cook it for exactly 1.5 minutes on each side. This will be your, oh, I gotta use fast QC. Or for another chef or another process, it will be, oh, I need to use this specific version of high set too. So this has helped me understand Nextflow a little bit better, where the processes are kind of like your chefs, your channels are your data moving systems or your food delivering system. Your workflow is the head chef and the directives are your rules. Cora asks, is it reasonable to say that the workflow is the script? No, because the workflow itself, and by all means, I apologize if that came out harshly, but the workflow itself is defined as a literal 10, 15, 20 lines at the bottom of the script itself. The script contains all of the steps and all of the processes and all of the channels, and the workflow is defined at the bottom. Perhaps they should have come up with a better name for it. In the earlier version of Nextflow, using DSL1, they did not have workflow at the bottom. They actually had each various channel being more explicit, each various process being more explicit. And if you wanted, and I did this a lot, I could follow this with a finger, whilst now is a little bit more difficult, and my finger goes all the way to the bottom, and it's looking at workflow right at the bottom. So I did not mean to be harsh, Cora. Thank you for the question. Okay, we are finally here. We are going to run the shortest example I could have come up with. There's a question. You're okay. Thank you. Thank you. All right. Here is the shortest example pipeline I could have come up with, and it runs Salmon Aligner. Salmon is one of the aligners that I did not talk about because it is not a quote-unquote traditional aligner. In a matter of fact, Salmon is a little bit different, where instead of aligning a specific read on top of the reference sequence itself, it just is okay with saying, it's around here. This is a process called pseudo alignment. And it does a lot quicker than just an alignment, but it allows to essentially, quote unquote, get a feel of how well a specific alignment would fit between a reference sequence and your reads. So I do also need to mention beforehand that this workshop has been heavily inspired. I took a bunch of data from Nextflow and essentially made the workflow in 1 hour. I think their time is roughly 3 hours, and that's why things feel a little bit rushy. Regardless, I did need to mention that there is a link to the entire workflow later on. So the alignment uses Salmon, which quantifies the expression levels of transcripts from the RNA-seq data. It does use pseudo alignment, and then it is going to create a fast queue to do quality control, and a multi-QC, which is going to take the data from FastQC and the quantification data from Salmon in order to, well, create a little summary. So extremely quick. We're essentially doing two things: alignment and quantification, and finding out the quantification of the alignment itself. So it's extremely simple to run. You do Nextflow space transcriptome underscore qc.nf. I'm going to copy this into the chat, and I'm going to show you how to launch it. We're going to go back to our data store, or Cypress's the discovery environment, and I'm going to do cd Nextflow tutorial. I'm going to copy this and paste it in the chat in case you need it. This is going to change my directory inside the tutorial itself. And here, if I do ls, my files are there. I can do Nextflow transcriptome underscore qc.sf. The screen is not shared. You cannot see my screen?
Yes, we can see your screen.
Okay. Maria, it sounds like people can see my screen.
She might be on the meeting tab as opposed to the Michele Kosi's screen tab. That is
Okay.
a new feature in Zoom that happened a couple weeks ago.
Maria, if you did not hear that
I got it.
in Zoom, maybe you have to click on
I
my
got it
name.
now. I didn't see that feature.
She got it? Okay,
Yeah,
cool.
that's tripped up a lot.
Okay.
Okay.
All right.
Okay, what's the folder we need to be in to run it?
It's called Nextflow tutorial. I pasted it in the chat. How to get there? CD Nextflow tutorial. Come around.
It's like I screwed up and I'm in work and now I'm like, how do I what what folder were we in? Okay.
All right, sorry, everybody, technical difficulties on our end. Okay, we're ready to run the pipeline itself, and it's gonna take roughly 5 seconds. And it's quite underwhelming. So I'm gonna click enter. Drum roll. Drum roll. And this is it. Congratulations, you have run Nextflow. I did mention earlier that I made this extremely foolproof, but it is not hard to run Nextflow, since Nextflow's main antagonists are within the Nextflow file itself. What I'm going to talk about right now is what are you seeing on the screen. So Nextflow allows, first of all, it detects when it's running. So it says, hey, I'm running. I'm going to be running this specific script, and I'm going to give it a nice, cute little name. And for me, it was festering Marconi. Within the script itself, I have a few lines which tell me where to find the data. In this specific case, we're looking at the G-Gallum transcriptome.fa, the G-Gallum gut FASTQ files, so the RNA-seq reads, and I have 4 different processes that happen. The processes are these ones right here. They are given a funny little name, such as A8. And then within A8, I'm going to show you in just a second, there is a really long string, and that is, in a way, where your working folder is. However, this does have a name, and that is index, and then it will also tell me when it is done. This is valid for the other 3 workflows, sorry, the other 3 processes as well. Notice how they were like 0 of 1, and they were just waiting. Oh, 1 of 1, I can go next. So if you would have a larger Nextflow, you could be 58 of 62, and then that output goes into another channel, and the other channel has 16 out of 11, or 16 out of 11 doesn't make sense, 16 of 20. So can you press cancel, please? So this was the fastest way for me to show you how Nextflow runs and how it renders when it runs. Since there is only 1 of each, it wasn't really fun. But that's why, if you look into the Nextflow tutorial data, I'm going to show right now. There is liver, lung, 1, 2, 1, 2. If you want, you can try to extend the Nextflow file itself in order to have more processes or increase the amount of a single process such that it actually looks like a specific workflow. But I want to take a step back and show you exactly what happened. So first things first, we told Nextflow, hey, Nextflow, enable DSL2. So we're enabling the Nextflow language. The first things that come right after that are the parameters. We talked about the parameters themselves, and here are, hey, we're loading up the parameters. There are 4 different parameters shown in params dot something, and these are where the reads are, where the transcriptome is, where you want the multi-QC to run, and where you want your output directory to be named. This is a fun little block that it's fun to write, which essentially it prints whether it was able to find the transcriptome files, the reads themselves and the output directory. I did not talk about directives outside of processes, but this is something like it, where, hey, instead of writing down the file entire path, you can just use transcriptome_file, so I don't have to write the path every single time. So this is where we get into our first index process, where I specify the name of the process, I explain through a directive what I want, what tool I want to use, and then I tell it, call the transcriptome file, create an index, run Salmon. That's all I had to say. If it feels weird to really boil it down to this, but this is an indexing process. It creates a binary index file from the transcriptome using Salmon. It uses a single directive, and it uses the Salmon that's present in the current environment. I then tell it which input and which outputs to use. Then, right after the process, I have a channel where it reads the reads, essentially channel from the file, from file pair, because we're looking for 1 and 2, look for reads. If you can't find it, print, hey, I can't find the reads. If not, create pair channel, create read pair channel. Then I can start the second process, which is the process of quantification. We're going back to Salmon right here, where I tell it, hey, take index as an input, and index, remember, is the process that we run first, as a tuple, and in computer language, a tuple is something that comes in twos. Take the values of the reads. I'm sorry, this is a little complicated, and run Salmon quantification on these. Reads 1 and reads 2, or in this specific case, reads 0 and read 1. Go and figure that one out. Are you a person that counts from 1 or a computer language that counts from 0? And then I say, create the quantification out. The next process is the FASTQ process. I'm not going to repeat myself once again, but essentially I tell it, create a, take the reads, create a folder, and run FastQC on the reads themselves. And then lastly, I tell MultiQC, create a single summary file for every statistic that you can find. MultiQC creates that specific files and it outputs it in a folder called, well, it's a folder called results. I don't want to scroll all the way up right now. Last but not least is workflow. And the workflow, as you can see here, tells what runs first, the second, the third, and the fourth. What's expected from the first process, what's expected from the second process, and so on. We can now view the results in the results folder, and that I'm going to do cd results. Pasting it in the chat. Where I can do ls, and I can see a single output, multi-QC report. I can actually go ahead and open it, but to open it, I will need to go here on the left where there is Nextflow tutorial and click results and multi-QC. If you do want to see the actual results, click this trust HTML. And all of a sudden, you have some data to read. Woohoo! Fantastic. I'm not going to go through the actual data itself. You feel free to explore. There is a number of results either from Salmon or FastQC that you can use to learn. We do have a couple of minutes left, and therefore I wanted to close with a couple of remarks and resources. And the first things that I need to say for a third or fourth time today is that this is by no means something simple to grasp, and it's impossible to really cover Nextflow in 1 hour. However, it is important for you to understand what happens when you're running even a simple workflow. What are channels? What are processes? What's workflow? And what are the directives themselves? We didn't talk about resume. We didn't talk about what's inside the work folder. How does it handle errors? And in what way can it check logs? So there is a lot of things that I could not have covered in 1 hour. However, this is extremely rewarding in a sense that, well, Nextflow is extremely good when it comes to containers and reproducibility. Containers are, well, pieces of containerized code that don't need specific OS to be run. It supports Slurms and PBS HPC systems. It is quote unquote easily shared. And if you know Nextflow, people are hiring. So please put it in your CV and people will come flocking for you to get hired. Is there any heuristic? Is there an heuristic for how configure your cloud instance in terms of memory and CPU based on the fact that they are using Nextflow? Yes, and that's one of those things that I did not cover. You can limit how much Nextflow can use, and that is if this is Nextflow, there's a small little file that you can create and essentially tell Nextflow, don't use everything. So there is a way to limit Nextflow. I'm gonna quickly Google it. Nextflow configuration file. Gonna copy this and paste it into the chat. And I believe this will help you understand. Yes, over here, for example, how many processes you can create, how much memory you can use. So it doesn't use everything that's available. I have here at the bottom a bunch of resources for you to use. General documentation, Nextflow training, which Maria has already shared. Find your favorite workflow, Nextflow workflow at NF Core. And earlier on, I showed this beautiful picture. If you are interested in RNA-seq or RNA-seq, go ahead and read that specific, extremely well-documented pipeline. We also have a webinar on Cybers on Nextflow. It is actually shorter than this, but it is taught by somebody that uses Nextflow on a regular basis. I have also a link to the original Nextflow tutorial from the Cicada Labs, which kind of own Nextflow. Feel free to run this in your own time. So I'm going to stop sharing, and I am going to thank you all for your attention. Before you go, if you could... Oh, what? Excuse me a second. Before you go, if you will be extremely nice, I would like for you to please, 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 once again, fill in the small short survey. It really helps with understanding if I'm doing bad, if I'm doing good, if I gotta go faster, if I gotta go slower, if you're not interested in what's being explored, if you want to cover something else in the future that's outside of this workshop, or go in more depth on something that's covered in this workshop. With that said, I truly appreciate your patience. Thank you very much, everybody. It's always been a pleasure. Thank you, Randall. Thank you, Sky. Thank you, Eric.